Now let's discuss how to resolve the second type of partial fraction. So you have this single fraction and we have to resolve it into its partial fractions. Now, we haven't dealt with this denominator before. So how do we proceed with this? Well, the partial fractions for such a fraction will basically have denominators that are in increasing power of the original denominator. So for example, this is x minus 1 whole cube. So the first partial fraction will be a over x minus 1 to the power 1. The second partial fraction will be b over x minus 1 to the power 2. And the third fraction will be c over x minus 1 whole to the power 3. And since that is the limit, this is where we'll stop. Now we have three partial fractions. Obviously, you'll have to take the LCM so that the denominators of the left-hand side and right-hand side can be equal. So obviously this a here, we must have this x minus 1 whole cube underneath every single partial fraction over here. So this a will be multiplied with x minus 1 whole square, so that this denominator will also be multiplied with x minus 1 whole square, and so that can give you x minus 1 whole cube. So a will be multiplied with x minus 1 whole square, b will be multiplied with x minus 1, and c will remain as it is since it has x minus 1 whole cube underneath as in its denominator. So now we have the left hand side equal to the right hand side, and now since both of the denominators are equal, they'll be cancelled out, and so we are just left with the numerators equal to each other. And so this is what you get. And obviously when you actually expand this x minus 1 whole square, you get this x plus 1 minus 2x, x squared plus 1 minus 2x, and b will be multiplied with x and minus 1, so bx minus b. And so in the end you get this equation. But really, this is the best way to solve this equation. Now, for argument's sake, let's just write down the first equation over here, which was 2x squared minus 3x plus 4. So 2x squared minus 3x plus 4. And what was that equal to? It was equal to a into x minus 1 whole square plus b into x minus 1 plus c. So a into x minus 1 whole square plus b into x minus 1 plus c. Now, when we put x is equal to 1 in equation 2, well, this entire part and this entire part will become 0 because this bracket will become 0. So when you replace x with 1 in this equation, you get c is equal to 3. So you have a value for c now. Now we have to find the values of a and b. Now, here's the best part. Remember, when you expand this part, you get basically, instead of just going through it ourselves, you get this. And so, well, we'll write this down over here. So we have a into x squared minus 2x plus 1 plus bx minus b plus c, and that will be equal to ax squared minus 2 ax plus a plus bx minus b plus c. And then that will basically tell you that a is the coefficient of x squared and minus 2a plus b are the coefficients of x, and then you have obviously plus a minus b plus c. So here's what you'll do. As you know that the coefficient of x square on the right hand side is 2, and the coefficient of x square on the the coefficient of x square on the left hand side is 2, and the coefficient of x square on the right hand side is a. So a is equal to 2, obviously. So that is how you get the value of a. Now, how will you get the value of x? Well, the coefficient of x on the right hand side is minus 2a plus b, and the coefficient of x on the left hand side is minus 3. So minus 2a plus b is equal to minus 3, obviously. And then you'll plug in the value of a you found here. So minus 2 into the value of a, which is 2, plus b is equal to 3. And when you resolve this, you find out that the value of b is 1. So now you have the values of c, the value of a, and the value of b. So when you plug that in to your original partial fractions, you get this equation. And hence, the fraction given in the question has been resolved.